Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Geometric translations, I think, are one of the easiest transformations for geometry students to do. These are just like reflections, a rigid transformation. So many people just call these a slide. Slide it to the left, slide it to the right, up, down, whatever. So they might use T for translation, and then X, comma, Y. And then they'll give you a triangle or another shape, ABC. And that's how you will go ahead and get your image. If X is positive, if this number is positive, you're moving it to the right. If it's negative, left. Y, if it's positive, you're moving it up. If it's negative, you're moving it down. So here we go. We're just going to draw a triangle DEF. And we want to go ahead and do this. Okay, so we could write down the ordered pairs and we could do this algebraically. We really could. Or we can just go from D, 1, 2, 3, 4, 5. 1, 2, 3, 4. From F, 1, 2, 3, 4, 5. 1, 2, 3, 4. And for me, 1, 2, 3, 4, 5. 1, 2, 3, 4. Boom, we're done. Or if we didn't want to count it all out, maybe it was written on paper and they just wanted to know the ordered pairs. We know that D is at negative 3, 1. E is at 0, 1, 2, 3. Yep. And F is at 0, 1. And since we want to go 5 right, we're adding 5 to the x's and down 4, so we're subtracting 4 to the y's. So adding 5, subtracting 4, adding 5, subtracting 4. So that means our image is going to be at 2, negative 3, 5, negative 1, and 5, negative 3. So we can do it that way as well. So again, this is just adding, subtracting to your x's, adding, subtracting to your y's. So let's say you are giving a p at negative 3, 1, and a image or a new p of 2, 3. What translation rule would do that? Well, you could always graph it, right? Left 3, up 1, right 2, up. So we have to go 1, 2, 3, 4, 5, up 2. Or we can see this as a plus 5 and a plus 2. So our translation would be 5, 2. So I really do feel like translations are one of those things that geometry students just, they grab, they've got it, not a big deal. So also, because of this, when I teach in my class, I also combined this particular day with something called composition. Now in math, eventually in algebra, you'll learn this as well. Compositions are represented with an open circle. It's in the same location as the time sign, but instead of a solid dot, it's an open dot. So it's not up high, not down low. And it means composition. A composition is kind of like a chain reaction, okay? So we might see something like this. R, x-axis of t, -3, 2, triangle x, y, z. Okay, so let's say we saw this, okay? It means that we're going to be doing a chain reaction of something. You're going to start with your triangle, then you're going to translate it, then you're going to reflect it. So it's a chain reaction. So let's go ahead and do that for the following triangle. X 5, 2, Y 7, 4, and Z 8, 3. Now, we could draw it, but we're going to be a rock star and we're going to do it without drawing it. So remember, left 3, up 2. So left 3, 5 minus 3 is 2. 2 plus 2 is 4. For our Y, we got to go left 3. So left 3 from 7 is 4. Up 2 from 4 is 6. And for our Z, left 3 would put us at 5. Up 2 would also put us at 5. Okay, now we have to do the reflection over the x-axis. And remember, anything up goes down, anything down goes up. So picture that. We'll just picture the first one. 2, 4 would go to 2, -4. So see how it just changes the y? So our next image would be 2, -4. So see how I'm using 2 to show that it's the second step. Forgot my marks. There we go. So if you're a visual person, go ahead and draw it out. Physically move it left 3 and up 2. Physically reflect it over the x-axis. But we can go ahead and do these just numerically as well. So again, a composition, you can think of it as a chain reaction. Do this and then do that. Okay, so somebody has written a chain reaction of this. And they've given us 2 different steps. So the first person wants us to go, so when we start doing this, remember we start at the end and work our way back, right? So we have to go left 5, up 7. Then after we do that, we have to go right 3, down 2. What would have been shorter to do? Instead of going left 5 and then right 3, couldn't I have combined those and just said, hey, how about you go left 2? Instead of going up 7 and then down 2, couldn't I have just said, hey, how about up 5? Absolutely. So sometimes a composition function can be written as a single function, depending on how it was written. Okay? So let's see what happens when we do one more composition and how it's going to affect and what we could have done instead. So we're going to do R, x equals 2 of R, x equals -1. Our triangle is going to have an x position of 5, 2. A y at 7, 4. And a z at 8, 3. So they want us to do a double reflection. and should have wrote like that. They're wanting us to reflect twice, but it's not over the x-axis or y-axis, so we're going to have to be really, really careful here, okay? So the first thing we're going to do is we're going to graph this. That way we can do it visually, since we may not be comfortable with reflections in their current state. Okay, so one, two, three, four, five, 1, 2, 6, 7, 3, 4, and Z. Okay, there's our XYZ. And we're supposed to reflect over x equals -1. Okay. So an x equals equation is a vertical line, right? So we can see here that the x part is 1, 2, 3, 4, 5, 6 spaces to the left, right? So I need to do 6 spaces to the left. Z is 9 spaces, so I need to do 9 spaces. And Y is 8 spaces, so I need to do 8 spaces. Okay. One, 2, 3, 4, 5, 6, 7, 1, 2. Eight, 9. Okay, now 8 to -1 is 9 spaces, and 9 spaces the other way is -10. 7 to -1 is 8 spaces, 8 spaces the other way is -9. 5 to -1 is 6 spaces, 6 spaces the other way is negative. So you could have done it that way. You could have said, okay, how far is each number from -1? And I'll go the opposite direction from that. So there are ways to do this with thought-provoking. I prefer not to. All right, our next step and our final step says to do a reflection over x equals 2. Okay, here's the line x equals 2. Notice I color-coded so that we could figure this out. So the x is 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So we got to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And therefore the z and the y. And you can count those out as well if you would like. I kind of went off the x so I didn't have to count so much because I know it's going to make a perfect shape. Is there a way that we could have said something shorter? So let's go ahead and get these points on. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2. 12, 3, whoops. 11, 2 was x. 12, 3 was z. 11, hold on. 11, 12, 13, 14. Ooh. 14, 3, and this was at 13, 3. Okay, and this time it was over the line x equals 2. So -7 to 2 is 9 spaces, so add another 9. -9 to 2 is 11 spaces, add another 11. -2 to 2 is 12 spaces. It's 12, add another 12 is 14. So with that said, we did a double transformation. We did 2 reflections. However, those 2 reflections because these lines were parallel, actually just resulted in a slide or a translation of 1, 2, 3, 4, 5, 6 to the right. Now see how they're only 3 apart? But it resulted in a translation of 6. That's not unusual, okay? In fact, that happens. So when you do a composition where those lines are parallel, it will equal a translation of 2 times the distance between the parallel lines. So that's kind of neat. It's because they were 3 apart, I could have just figured out that it was going to do a translation of 6. So composition, again, is just a chain reaction. They're going to have an open circle to show that.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.